Okay, so we're gonna practice computing the inverse of this function, which is both 1-to-1 and onto. Then we're going to talk a little bit about restricting our domains to create an inverse, and then we're going to cover one last interesting thing. So to compute the inverse, there are two techniques we can use at this point. We can either algebraically manipulate the function, or we can reflect the graph about the y equals x line. Now, to uh, algebraically manipulate the function, what we do is we write down the original function. We isolate for x. We then switch our x and our y. And finally, we write the result for the f inverse of x equaling y. So let's take a look at this example. We're going to write it down as y equals 2x cubed plus 1. Now we're going to try to get x by itself. So it becomes y minus 1 equals 2x cubed. Y minus 1 over 2 equals x cubed. Y minus 1 over 2 to the cubed root equals x. Okay. Now that we have this expression, we're going to switch our x and our y. So y equals the cubed root of x minus 1 over 2. And finally, f inverse of x equals the cubed root of x minus 1 over 2. Lovely. Now we're going to look at computing the inverse of the graph by reflecting about the y equals x line. If we look here, we've got our two functions. We've got square root of x, and we've got e to the x. Now, if I take a line, y, or if I take the line y equals x, there. Let's undo a bunch of stuff, make it look nice. See if I can insert a here. Kind of looks like that. That's my line. If I reflect about that line, I get curve that looks like this. And that curve looks a lot like x squared. Okay. Lovely. And if we reflect the e to the x about our y equals x line, we get the curve that looks like this. And that curve is ln. Okay. So one curve looks a lot like x squared. The other curve looks a lot like x, or ln of x. Now, if we look at our square root of x, we have a domain and range restriction. Our domain for the square root of x is greater than or equal to 0, and our range is going to be greater than or equal to 0. Which means the inverse of x equals x squared with the domain greater than or equal to 0. We have a restricted domain. Now, with this restricted domain, this lends the idea of a restricted function. A restricted function is a function where the domain is restricted to a subset of the natural domain, or a smaller portion than the natural domain. There are reasons to restricted functions, and we're going to explore this to define invertible functions, specifically our inverse trig functions. By restricting the domain for our trig functions, we can then create an inverse for the trig functions. Okay? Now, here, if I take this function here, and I restrict its domain from minus infinity to -1, use the horizontal line test to prove that it is invertible. And additionally, compute the inverse. Okay? So this function here is invertible and it has an inverse. Okay? Now, I would highly suggest to practice this problem. Okay? It would be a great problem to practice.